let's take a minute to understand the idea of relative rate of change. Recall, we studied the idea of relative change by looking at comparing the change in populations to Williamsburg, Mass. Versus New York City. To quantify that there is a difference between adding 2,000 people to Williamsburg versus 2,000 people to New York City, we came up with the idea of relative change. Here, we look at our total change, delta y, but divide it by the original amount, y. Just like with change, it is sometimes important to compare the rate of change to the original amount. We call this the relative rate of change, and it's written as y prime divided by y. Notice here that we've replaced the idea of change with rate of change and replaced delta y, our change, with y prime, rate of change. Just like with relative change, it's an idea that we'll want to keep in mind when doing some of our applications. Now let's look at an example of relative rate of change. Let's find the relative rate of change for the function y equals 2 to the x at x equals 1. To calculate relative rate of change, we need to know y prime over our function y. In particular, we're looking at y prime at 1 over y at 1. To find y at 1, we just need to evaluate our function 2 to the x at x equals 1, which is 2. The derivative y prime at 1 is roughly 1.38629. Recall that we calculated this previously using the definition of derivative and taking smaller and smaller values of delta x. So the relative rate of change that we were looking for, y prime of 1 over y at 1, is roughly 1.38629 over 2, which is 0.69315. So the relative rate of change of y equals 2 to the x at x equals 1 is 0.69315.